Hello, I am Seema and welcome to part 36 of the chapter Hydrocarbons. We have been talking about the chemical properties of alkynes. In the previous video, I did the acidic character of alkynes. In this video, we are going to talk about the addition reactions, and after this there is one more property of alkynes that is in your syllabus, which is polymerization. So let us start with addition reactions in the case of alkynes. Why does addition take place in the case of alkynes is something that I have already discussed with you. Addition takes place because alkynes are unsaturated hydrocarbons. If my tummy is empty, I can eat more food. I can add more food to it. It is unsaturated. It's the same case with unsaturated hydrocarbons. Both alkenes and alkynes have got multiple bonds. Alkenes have double bonds and alkynes have triple bonds between two carbon atoms. The presence of the first bond is a sigma bond. The other two bonds are pi bonds in alkynes. The pi bonds are weaker and they can easily break, and those electrons, the two electrons which make a pi bond, are actually available for bonding. So it's very easy for compounds to attack such compounds and add on to the molecule, and that's the reason why addition reactions are seen in the case of alkenes and alkynes. So unsaturation, or the presence of the triple bond between two carbon atoms, is responsible for addition reactions. So what does the addition take place of? Addition of usually hydrogen, halogens and hydrogen halides takes place in alkynes. In the case of alkenes, one molecule of hydrogen or a halogen or a hydrogen halide would take place. But in alkynes, there are two pi bonds. Therefore, two molecules add to the molecule and make it a saturated compound. So, two molecules of either hydrogen or halogens or hydrogen halides or water takes place in unsaturated alkynes and turns them into saturated compounds. Now this addition that takes place is electrophilic in nature. Electrophilic means that the reaction takes place in two steps, and the first species that attacks the bonds or the carbon-carbon multiple bonds is an electrophile. As I told you, that these multiple bonds, that is the pi bonds, they have electrons which are called pi electrons. These pi electrons are loose, or they are not as strongly bound as the sigma bond electrons. So these pi electrons are available for reaction. So when these pi electrons are available, they kind of render a kind of a negative character to the two carbons which have the pi bonds. So due to the presence of these electrons which are negatively charged, you would say a little excess of negative charge or kind of a negative character is present here between the two carbon atoms. So any attacking agent, the positive part of that attacking agent will come and attack the carbon-carbon multiple bond. And whenever a positive part of a molecule attacks in a reaction, we call it an electrophilic addition or an electrophilic, even substitution takes place where an electrophile would attack first. So here also the electrophile is attacking first, therefore it is an electrophilic reaction, and since it is an addition reaction, it is known as an electrophilic addition reaction. Just as electrophilic substitution reactions also, electrophilic addition reactions also take place in steps. The first step would obviously be the attacking of an electrophile. What is an electrophile? Phile means love, right? So anything, a species or a part of a molecule that loves electrons. Electrons are negatively charged. So which part of a molecule would be electrophilic? That part which is positive would be attracted to the negative part. So the positive part first, in the case of hydrogen halides, what will happen? Hydrogen, which is combined with a halogen or any other negative part. The hydrogen is the positive part. So in the first step, the hydrogen attacks the triple bond, or the carbons which have the triple bond, or the electron dense center. So the hydrogen is the electrophile here. It results in the formation of an intermediate which is a carbocation. Carbocation means a cation which has positive charge on a carbon. If the positively charged electrophile adds to one of the carbons, it is positively charged, therefore it uses both the electrons of both the pi electrons and forms a bond with one carbon, as happened in this case. That the triple bond, one bond broke, and the two electrons of that bond were used up by this carbon, the first carbon, to add the electrophile which was H positive. So what is left? Z negative is left now. So in the first step, only H positive added, and since both the electrons of the triple bond, the pi bond, they were used up to form the bond with hydrogen, now this carbon becomes deficient in electrons and becomes positively charged. Since positive charge is present on carbon, it is called a carbocation. So a carbocation is formed in this case, since it was vinyl, it is vinylic carbocation or vinylic cation. In the second step, the negative part of the addendum, this is the addendum, the molecule that gets added on is known as the addendum. The positive part, which was the electrophilic part, added first and resulted in the formation of the vinylic cation. And in the second step, the negative part, when the bond between hydrogen and Z breaks, it is a heterolytic cleavage. Why is it a heterolytic cleavage? Because the Z part is electronegative. It takes both the electrons and hydrogen becomes H positive, and it is that H positive which adds which acts as an electrophile. So this Z, which has two electrons, both the electrons of the bond, is negatively charged. In the second step, the negative charge will be attracted to the positive charge, therefore the Z will come and get attached to the second carbon. So Z gets attached to the second carbon. And then in the next step, this is an alkene. In the next step, again the H and Z can add on and remove the second pi bond also. Now it is important to remember here that when the second addition takes place, it again has a positive part, hydrogen, and a negative part. The second addition would take place according to Markovnikov rule. What was the Markovnikov rule? Let us remember that again. According to Markovnikov, the negative part of the addendum, that is in the second step, the positive part of the addendum adds first, but the negative part of the addendum always adds to that carbon which already has lesser number of hydrogens, right? So the second addition that will take place, when the negative part adds in the second step to turn it into a saturated hydrocarbon, both the negative parts will come and add to this carbon. Why? Because this one has more hydrogens, and the negative part of the addendum adds to that carbon which already has lesser number of hydrogens. So if Z has to add on here, the Z will come and add in the next step to the same carbon, and the second hydrogen will add to this carbon. So you will have the saturated hydrocarbon. You will understand this better as I explain these examples. So the Markovnikov addition is seen in the case of unsymmetrical alkynes. It is not seen in the case of symmetrical alkynes in the first step, but in the second step, of course, that would again be visible. But Markovnikov addition actually takes place even in the case of compounds which are symmetrical, where the addition of the molecule that is taking place is also has symmetrical atoms. I'll just explain it to you. Or rather, not Markovnikov addition, but what should I call it? The electrophilic addition. Now here you have ethyne, okay, in this example, and we are adding hydrogen, addition of H2. Now hydrogen, in hydrogen molecule, both the hydrogens are HH, they are bound by a covalent bond. Both of them have the same electronegativity. It is a non-polar molecule. But as soon as the hydrogen molecule comes closer to the ethyne molecule, the high electron density between the two carbons, which is rendering it negative, will polarize the hydrogen molecule. As they come close, it will polarize the hydrogen molecule, and that hydrogen atom, which is closer to the triple bond, will kind of become positively charged. Why? Because when the two hydrogens come close to the triple bond, which is high electron density, it will repel the electrons of this hydrogen, and therefore the electrons of this hydrogen will move towards the other hydrogen. So that hydrogen becomes kind of partially negative, and this hydrogen becomes partially positive. When breaking of the molecule takes place, it will be heterolytic cleavage. It will not be a homolytic cleavage. Heterolytic cleavage will take place, and when heterolytic cleavage takes place, the positive hydrogen will come and add to one of the carbons, and the other carbon will become negatively charged. Now, as a result of that, the second hydrogen, which was negatively charged due to the polarization that was caused and due to the heterolytic cleavage, that negative part will now add on to the other carbon, which is now positively charged. Right? As soon as H positive adds to one carbon, the other carbon becomes positively charged. Do you see here? So it kind of turns into a carbocation, and then the second hydrogen atom, which was negatively charged, will add to the second carbon because it has lesser number of hydrogens. This one has already added a hydrogen to it. But this is usually not explained here because this appears to be, the H2 also appears to be identical, and here also you see that the Markovnikov addition will be seen in the next step now. So in the next step, what will happen? In the next step, it is an alkene. It again has unsaturation here. The hydrogen will be attracted to it. It will be polarized, and the same thing will happen, and you will get a product that is ethane. And here I will not explain the Markovnikov addition because it becomes clearer when you have different atoms. Like both the atoms, one is electropositive and one is electronegative. There the products are different and you can tell the difference. Here it appears to be identical, so we do not usually explain the Markovnikov rule when you have identical species or identical atoms which are adding on. Here this is unsymmetrical, therefore of course here also the Markovnikov addition should take place, but we will be taking up the Markovnikov addition in the third example. So let me just explain what happens when hydrogen adds on. What are the conditions of this reaction? Hydrogen adds on, or addition of hydrogen is known as reduction. So reduction takes place in the presence of platinum, palladium or nickel catalysts. And when hydrogen is added in the presence of platinum, palladium or nickel to propyne, you again get propene in the first step. One molecule of hydrogen adds to both the pi bond. One pi bond breaks, one hydrogen adds here, one hydrogen adds here. So you get an alkene in the second step. In the next step, another hydrogen molecule will add on and you will get propane. Okay, so this was addition of hydrogen. We now come to the addition of halogens. The same thing again, we had hydrogen, both were electropositive but both had the same electronegativity, so it was a non-polar molecule, which I told you was polarized due to the electrons. The same thing happens with bromine also, but now bromine is already pretty electronegative. But both the bromines are identical in their electronegativities, so we will see a similar kind of addition. So I'll explain it just as I did in the case of hydrogen. When halogens add on, what happens? When halogens add up, it also takes place in two steps. In the first step, one molecule of halogen will add. So bromine molecule adds on to this, one pi bond breaks, one bromine adds here to one carbon, one bromine adds to the second carbon. In the second step, the bromine again, since both of them are bromine, again the bromine adds, the pi bond breaks here, and both the bromines, they add to the two carbons which had the pi bonds. So what is formed? It is 1122 tetrabromo 1122 tetrabromo propane are formed. And bromine is a brown colored liquid. And as you add bromine to this, as this reaction takes place, the brown color vanishes because the bromine is used up to form the product. So the bromine is consumed, which is brown in color, and the brown color is discharged, or the brown color is lost, or it becomes lighter. That discharge of brown color, you actually add so little of it to the reaction mixture that the brown color vanishes. When it vanishes, you can tell that the compound must have been unsaturated because addition of bromine has taken place. So this reaction hydrogen cannot be used as a test for unsaturation. But addition of halogens, that is addition of bromine specifically, can be used as a test for unsaturation because it loses color and it is visible to the naked eye. In the laboratory, it becomes easy for us to tell that this brown color has now been lost, which means addition reaction has taken place. So this was addition of bromine to alkynes. Let us now come to the addition of hydrogen halides. Now hydrogen is positive and the halogen is negative, and it results here the effect of the Markovnikov addition or the Markovnikov rule and the electrophilic addition will be very pronounced and will be very clear in the product. And this is where it is really important to memorize it for your exams. Here you know this was also a similar reaction, but since the product seemed to be simpler, it's not that difficult to remember it. But you must not confuse that you are getting different products because of simply because it is H2 and Br2. The process or the mechanism is the same, only here it is not apparent. But in this case, you can afford to forget it here, but here you cannot afford to forget that the addition has to be Markovnikov, the addition has to be an electrophilic addition. Let us see what happens. When HBr is added to ethyne, we find in the first step the H is positive, so the positive part will come and attach itself to one of the carbons, the pi bond will break and a double bond remains between them. Hydrogen comes and adds on here, and obviously bromine will add on to the other carbon. So you will get bromoethene in the first step. In the next step now, when bromine has to be added and hydrogen, in the next step when this bond breaks, the negative part of the addendum should add to that carbon which has lesser number of hydrogens. So we already know that this carbon, the bromine added to this carbon has 2 hydrogens while this one has only 1 hydrogen. So in the next step, the bromine will add to this carbon and not this carbon specifically, because the addition is electrophilic, because the addition is according to Markovnikov rule. So now when the addition takes place, what do you get here? CHBr2, CH3. So CHBr2, this is just the same molecule which has been reversed. This becomes CH3 and this becomes CHBr2. Both the bromines will add to the same carbon, so you get 1,1 dibromoethane. Right? If you had an unsymmetrical alkene, this would become even more pronounced. In the unsymmetrical alkene, you will get in the first step, the bromine, Markovnikov addition will be seen in the first step itself. Why? Because here the alkyne is unsymmetrical. Since it is unsymmetrical, already this carbon has lesser number of hydrogens. So it is understood when the addition takes place, the bromine will add to this carbon and not this carbon. Even in the first step, you will notice the Markovnikov addition. So electrophilic addition takes place, the hydrogen part will add first to this carbon and result in the carbocation positive charge on this carbon. In the second step, the Br negative will add on to this carbon. Therefore, you will get 2-bromopropene as the intermediate. In the second step, more bromine will be added. Br2, another molecule of Br2 will be added here. I should have written a Br2 here. And it will result in the formation of, now again Markovnikov addition will take place. This carbon already has less number of hydrogens, so the bromine of this molecule will add to this carbon. So the same carbon has 2 bromine atoms, and this carbon, the addition, it gets another hydrogen. So you get CH3, C, Br, and CH3. So it is 2,2-dibromopropane is the compound that you will get. I hope I am clear. What are you paying attention on? You're paying attention that this is an electrophilic addition reaction and it is following Markovnikov rule. If you have these two things in mind, you will always get the correct product. So let us now come to the fourth kind of reaction, which is addition of water. When addition of water takes place, before I explain this reaction to you, let us now remember what we have done about, what we have talked about the reactivity of alkanes and alkenes with water. I told you that alkanes and alkenes are pretty non-polar in nature, so are alkynes, and therefore they do not react with water. One, they do not react with water. Two, they are immiscible in water. Being non-polar in nature and water being polar in nature, they do not dissolve in water. Because like dissolves like, polar solutes dissolve in polar solvents and non-polar solutes dissolve in non-polar solvents. Water is a polar solvent, and the alkenes, alkanes and alkynes, they are non-polar in nature, therefore they do not dissolve in water. And they do not react with water either. But alkynes, since they have a triple bond, you can force alkynes to react with water. And when you force alkynes to react with water, the water molecule, being polar in nature, has H positive and OH negative. So the addition that takes place is electrophilic addition. And it is electrophilic addition, it will be Markovnikov addition. But once the intermediate, that is the alkene, is formed, once the triple bond breaks and the double bond is formed, the alkene part does not react with water further in the next step. Rather, after the alkene part is formed, isomerization takes place and you get a different product. This is the difference between the reaction of water and the reaction of hydrogen halides and the other reactions of addition of pure hydrogen or pure halogens. So let us see what happens. Here you have ethyne, and ethyne is attacked by HOH, that is water molecule. When water molecule reacts with ethyne, the H positive gets attracted to the electrons, that is the pi electrons, and the pi bond breaks and adds on the H positive to one of the carbons. And the OH negative, this becomes positively charged, and therefore the OH negative in the second step will come and get attached to the other carbon. When OH comes and attaches and the negative charge will be lost because this carbon was positive and the OH was negative, it used those electrons to form the bond, therefore it becomes, you get the neutral molecule. And now since you have CH2 double bond COH, what is this molecule? This is ethanol, right? It is ethanol. Now ethanol is an alkene even in the presence of mercuric sulfate and sulfuric acid. Now this reaction does not take place at normal temperature. Alkynes can be made to react with water under certain conditions. What are the conditions? We use mercuric sulfate, which is a salt, and we add sulfuric acid, which is an acid. So the acidic medium, the water is not very polar, but the acidic medium and the presence of a salt will make water even more polar and kind of promote this reaction. So we use these as a catalyst, the mercuric sulfate and sulfuric acid, and will result in the formation of alkenol. Once the alkenol is formed, it is an alkene. An alkene, even in the presence of an acid or mercuric sulfate, does not react with water. So you will not get a saturated product here. At this step, the reaction with water stops, but since you have an alkenol, it is not very stable. Isomerization reaction takes place. That is, what is isomerization? The arrangement of the atoms changes so as to change the functional group. So you get CH2, you had CH2, COHH, the hydrogen here, the pi bond here breaks and forms the double bond with oxygen. Instead of forming a double bond between two carbon atoms, the double bond will be formed with oxygen because oxygen is more electronegative. It will pull that shared pair of electrons towards itself. Therefore, this pair of electrons, a double bond, will be more stable on oxygen. So the double bond comes down here to oxygen and the hydrogen goes up to this carbon and results in the formation of CH3. So CH3CHO is ethanol and aldehyde is formed. Take another case now. Propyne. Propyne is an unsymmetrical alkyne. Unsymmetrical alkyne where now you will see Markovnikov addition, and of course the addition is electrophilic. In the first step, hydrogen will add. hydrogen will, now according to Markovnikov, OH is the negative part of the addendum, OH negative. So the negative part of the addendum should add to that carbon which has less number of hydrogen atoms. And we see that this carbon has less number of hydrogen atoms. So obviously the OH will add to this carbon and the hydrogen will add to this carbon. So you get CH3 remains as such. These two carbons had the triple bond, one bond breaks, hydrogen adds to this carbon and the OH adds to this carbon. And then in the next step, now since the propanol is formed, propene 2-ol is formed, this propanol cannot further undergo addition reaction, therefore isomerization occurs and an aldehyde is formed. So CH3, here you'll get a ketone, CH3CO, CH3. So CH3CO, yeah. So in this case, here you got an aldehyde, and in this case you'll get a ketone is formed. So you see CH3CO, CH3. That is, propanone is formed. So this was the addition reactions in the case of alkynes. In the next video, I'll be discussing polymerization in alkynes. So with this, I'll wind up this video. If you wish to watch other videos of this chapter, please click the link that appears on top of the video. And if you found this video helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.